So yesterday we started talking about confidence intervals for means. We said that there's two types. There's one for Z and there's one for T. T is when the population standard deviation is not given. Z is when it is given. Okay, so Z-score charts we use when it's a Z. T-score charts, which are on the back, which is the left side of the back of your Z-score charts, we use when it's T. Okay, so this right here, we should be able to tell at the very beginning whether we're doing T or Z. And that's one of the first things we should tell when we're doing a problem. Okay, and then we talked about what is T, a background before T has greater variability, greater uncertainty, more area in the tails, right? Degrees of freedom we talked about. As sample size goes up, degrees of freedom goes up. If we have a degrees of freedom of infinite, that means we're at Z, right? Z is kind of that perfect world, which doesn't really happen, but that's what it would be. And then we talked about the same type of thing for T models, and then we looked at these are the two formulas. We practiced how to find T critical, right? We did that. These are the steps for the confidence interval. Number one is the same. You guys have been doing number one since last chapter, right? You did one of those. We still have to do that. Test statistic, conditions, assumptions, calculations, and then conclusion. Okay. So we did one. We did student GPAs, right? We did GPAs of students at Central High School for East and West combined. We did that. So we left off on example number two. Example number two, chocolate chip cookie question. Okay. So here we go. Let's pretend that the Chips Ahoy company claims a mean of 24 chips per cookie. Does that mean every single cookie they produced has 24? No. What does that mean? Exactly. For every one that goes above 24, there's an equal number of cookies that are below 24, right? So for every one cookie that goes 2 chips over, there's one cookie that goes 2 chips under. They kind of balance each other out. Okay. So if I randomly go to the store and pull out a Chips Ahoy cookie and count the chips, and there are not 24, that doesn't mean they're liars, right? Because there's also one out there that could balance it out, right? They said if you had all of the Chips Ahoy cookies in a big pile and you found the average of all of them, it would be 24. Okay. So it's important to note that. Do we have statistical evidence to doubt them? Okay, suppose we take a random sample of 10 of the company's cookies and we get the following counts for number of chips. Okay. So each one of them represents a cookie. There's 10 cookies. This is how many chips they have. Okay. So what we're going to do is let's do a different one. We've done a 95. It doesn't say, like I said, in the notes, they don't tell you, but in the questions they will tell you. You guys have seen that on your homework. They always tell you what percent confidence level they want. Let's do a 98% since we've done 95% last time. Let's do 98%. Okay, we could have done 95. Like I said, on tests, on quizzes, I will tell you. Okay, I don't want you to worry that, oh, well, they don't tell me. They will tell you. Okay. Okay, so if we're going to do a confidence interval, the first thing we have to do is population parameter. Okay. So what are we trying to find here? That's what the population parameter is. What are we trying to find? There you go. True mean, number of chips in a Chips Ahoy cookie. That's what we're trying to find. Oh, before that, we didn't pull information. We pulled one bit of information, the information I gave you here, but what else can we pull from the sample size 10? So N10, definitely important. Yep, the true they claim is 24, so we're going to use that for 24. What's that? Yes, SRS. So when we get there, it'll be stated for sure. What else can we pull up? It's a means question. That's always important, right? It's obvious on our notes because this is all means, right? But not on test day. You guys saw in chapter 7 tests, I didn't tell you which one was means and which one's proportions. Good. What is, I don't want to say the most important, but something we missed that's gonna determine. Is it a Z or T? Yeah. So is it a Z or T? Do I know this number here? No. So this is a T model. We're using T. Again, most of the time you're going to use T. Okay. All right. So we already did step 1. Step 2, test statistic or formula. This labels which, this tells them, hey, we're doing this interval. Okay. So since it's T, we're going to use this guy right here. This is the guy we're going to use right here. Same one we used for the GPA question we did yesterday. We don't have S. Yeah, we'll get to it. We'll get to it in a second. Yeah, I know where you're headed, and we'll get to it. T critical S over the square root of n. Okay. Okay. Assumptions, conditions. We're going to check those out. Number 1, SRS. We said earlier it's stated. Good. Number 2, 10% condition. So N is less than or equal to 10% of big N. So N in this case is 10. Less than or equal to 10% of big N. So do I know, do they give me a number for big N? Nope. So what in words, how would we describe in words what big N is? Not all Chips Ahoy cookies, all, there you go, just the chocolate chips. Yeah, all chocolate, all chips in their cookies. All chips in Chips Ahoy cookies, yeah. Okay. Okay, number 3. Normality. So we have 3 options for normality since it's means. Let's see here. Right, let's go back to that. Right here. Boxed in red. Given population is roughly normally distributed. So did they tell us that in the prompt? Nope. So we skip that one. They didn't tell us, but our sample size is large enough. Is our sample size large enough? No. So we got to go to number 3. We have to graph it. So you can graph it using a dot plot by hand, or you can use your calculator. I would suggest using a calculator since it's easier to do. Okay. So scratch out 2 numbers. What do you mean? Oh, there's 12 numbers? No, don't scratch out 2. So we'll just change n to 12. It was just a typo then. Yeah, n must have been 12. It was just a typo. Okay. Okay, so how do we graph again? What do we got to do first? Stat. Edit. Good. So put the numbers in L1, right? That's the first step. Put the data in the calculator. Okay. So what do we got? 21, 28, 19. 2 19s. 23, 18. And then 18, 19. Okay. 12 numbers total. All right. Okay, so what do we do now? Now we want to graph. So what do we go now? There you go. Stat plot, which is y equals second, y equals. Good. That's where all the graphs are. 1, 2, and 3 are the plots. So we'll use 1 since it's the only graph we're going to have. So we'll use 1. Make sure it says on, and make sure it's blinking on, or else it won't show. Which graph are we going to pick? Yep, the one I'm on right now. The one I'm blinking on right now. The one I'm blinking on right now. Why is that one the one we're going to use? Because it tells me if I also have outliers, which is something I also got to check, right? So it's going to do 2 and 1. It's going to give me a graph and it'll tell me if there's any outliers. Okay. So I hit enter. My list is in L1. Frequency, just leave it at 1. The mark will tell you where the outliers are. Okay. So how do I see the graph? Zoom 9, which is zoom stat. Yep. There we go. So this is what we're going to do. We're going to draw that picture on our conditions assumptions. Okay. So let's go back to our conditions assumptions and we're going to draw that picture. Right here. Okay. So just sketch it the best you can. Doesn't have to be perfect. Just give it a decent rendering. Okay. Okay. So what it said was, let's go back to that page. Number 3, option number 3 says check graph and check for plausible normality. So watch out for outliers. Were there any outliers? So we're going to write that. We're going to say no outliers. Now, strong skewness. So let's go back and look at this guy here. Okay, so first thing we're going to say is no outliers. That we know for sure. Is this a case of strong skewness? What makes it strong skewness versus just regular skewness? Hmm. So this guy right here, I agree. This guy right here, the distance here is a lot shorter than the distance here, right? So it's skew, but is it strong? I don't think it's strong. It's skewed. It's definitely skewed. It's skewed to the right. I definitely would say it's skewed to the right. I don't disagree with you there. It's not strong though. Strong would be like, and then the other thing is look at the other parts of it, right? 25% here, 25% here, 25% here, 25% here, right? One of them is definitely longer. One side is definitely the longest right there, right? But then are the others that far different from each other? These guys are kind of the same, right? And then this guy's maybe a little bit more. It's not crazy where like strong skewness in my mind would be like if it was like right here and this guy was like right here and this guy was like oh this guy, let's see, that would be crazy skew. Okay, what would cause that to happen? An outlier. So that's why it didn't say on here, it didn't say, it just said watch for outliers. I added this part in over here. That's what mainly what you're looking for. You're looking for outliers, outliers that would really throw the skewness off, right? So even though it is skew, you can put that. Though skew, there are no outliers. Okay. So this guy right here, I would be no outliers. We could say no outliers present. Okay. Huh? So if there was an outlier, we obviously our picture would be different, right? So let's say we'd have that, and we do this, and we move on. Next step, right? It doesn't change. That's the biggest mistake I've seen. I've seen students do this on tests where they see something, they see an outlier, and then they stop and they're like, I'm done with it. And then they get their grade back and they lose half the points. And I'm like, they're like, why did I lose half the points? I'm like, well, you didn't finish the confidence interval. You didn't get the points for that. And they're like, well, I didn't think I should. No, you just note it. All you do is you note it and you move on. Okay. So make sure you don't do that. Yeah. Note it, move on as if it didn't happen. Okay. Just have it in your notes, have it in there, that, and then keep going because you don't want to lose credit over everything else. Okay. Also, another thing, I'm starting to see this, and you guys aren't the only ones. Every year I have this. Every year I have to bring this up. This part here. Look how on mine this is the whole page, right? On most, everyone tries to cram it into like this little corner here, this very little corner here, and it only gets smaller. So in chapter 7 it starts small, chapter 8 it gets smaller, chapter 9 it gets smaller, chapter 10 it gets even smaller, right? And then I have to end up taking off points because I can't read the thing. Okay, so don't be afraid to take up. Don't be afraid. And this is not. I'm not picking on one person. This is everyone. Okay, I think only one person had it big enough so like it was like good. Okay, this is worth the same amount of points as the other parts, right? So you want this to be big, just as big as your calculations, just as big as everything else, right? As your conclusion, right? Because it's worth the same amount of points. Okay, so don't let it get smaller. If anything, let it get bigger. Keep it organized. Okay, I'm not talking about handwriting. I can't complain about handwriting. I have terrible handwriting. I know that. But if it's small and it's bad handwriting, it's even harder to read. Okay. So that's why I make mine big, because it's big and you can read it semi-legibly. Okay. So if you need more paper, so even though I give you like this much paper, right? Like a good chunk, if you need more, tell me. Okay. Or go to the back. Okay. So you don't have to fit everything in there. Okay. I try to give you as much room as I can, but sometimes you need more room. Okay. So don't not at the expense of your conditions or assumptions. Okay, because like I said, we're going to be doing this for the next few chapters, and they only tend to get smaller. Like I said, by the time we're in chapter 10, you guys, they'll be so tiny, it'll be hard to read, right? It's an afterthought. Well, this is just as much points as these two. This is just as many points as these two guys, right? So make sure you have them, show them. Okay, next thing is now our calculations. Okay, our calculations, let's see here. We have, okay, so let's go back to our test statistic. Uh-oh, I'm missing a few things. I can find this. I know what this is, but I don't know what this is, and I don't know what that is. So how do I do that? Calculator. Okay, don't you have you have it already in L1, right? So tell me what X bar is going to be. 20.9166. Okay. So we'll go say 20.917. Good. Okay. So that's something we should have had over here. X bar equals 20.917. And then standard deviation. 3.707. Yes, S of X. Yeah, give me X of X.
3.872. How'd you get that, George? 3.8. One variable size. One variable size. Is it wrong? Is it different numbers? What's the frequently? Frequency. Isn't that just L1? Oh, yeah, it's huge.
3.872.
How'd you get that? I got 4.204. Yeah, that's what I got too. Maybe
Let's see.
Did you get for standard deviation?
What'd you get the mean?
I got 23.126.
Oh, frequency list. Frequency list. Turn that off.
Oh.
Turn it off. Frequency list. We don't need a frequency list. Is if you have probabilities. I don't have probabilities. So if I had probabilities in there, that's what I say. So turn that off.
Okay, Josh, what'd you get for the mean? 20.9166. I got 22.33 repeating.
21.75.
Oh, I went to fall for it. You probably got the number right. 21.
Yeah, it was probably just entering the numbers. 21.75.
Yeah, I got that too. 4.02.
And then S of X is 4.025.
You figured out? Yeah. I'm doing 17 instead of 27.
That's usually what happens.
What did I do wrong?
Okay. All right, so let's go back there. So now that we have those, we can go to T critical. What's T critical going to be? How do we find T critical? So what do we do first from the chart? We're definitely going to use the chart. So we're definitely going to use the T chart, which is on the back of the Z-score chart. Where did it go? There we go. So where do we start first? So it's going to be a 98. So we're going to go 98 is here. So it's going to be one of these numbers in green. So degrees of freedom is n minus 1, which is 11. So we're going to go 11. And we got it right there. 2.718. Times standard deviation over square root of 12. Okay, so 4.025. Okay. You could crunch those numbers, or we could just go to Zoom test. Probably easier to go to Zoom test since we have that capability. Or Zoom stat test. Zoom or stat, and then we're going to go over to test. And then which one are we going to choose? Yeah, but it's under tests. It's under the test category. Zoom stat tests. And then which one are we going to choose? T interval, just like we did yesterday. Good. So stats means I have the data. Data means I have the actual numbers. So if you have the actual numbers, you should always use data. Yesterday, we didn't have the numbers for the GPAs, so we use stats. Here, I have the data, and it's in L1. Use that. Okay? Instead of putting in the numbers here, the numbers are going to be the same here, because the calculator will enter it on its own, but it's always good to use if you have the numbers. The lists are in L1, frequency is 1. Am I in T interval? Yeah, we're in T interval, right? 98% confidence interval. There we go. 18.591. 24.909. Okay. All right. Last step is making sense of those numbers. Because just as important as those numbers is making sense of them. What do they mean? We know we have an interval that goes from about 18.5 to almost 25, but what does that mean? What are those what in the world are they talking about? So we got a conclusion. Okay. We are blank percent confident that the true mean, and then you fill in your population parameter. This is where your population parameter comes in handy. Copy that in, is between blank and blank. So we are blank percent confident. So this one we are 98% confident. 98% confident that the true mean number of chips in a Chips Ahoy cookie is between 18.591 and 24.909. Done. So now we're going to go back to the question. We haven't answered the question. Sometimes they'll just say, if they just say, like in your homework, it said, perform a 98% confidence interval. You're done. but sometimes there will be follow-up questions based off that. So we have to use it to answer. And like this one. This one had a follow-up question. Do we have statistical evidence to doubt them? So right here. Do we have statistical evidence to doubt their claim? Their claim is right here. That's their claim right there. This guy was their claim. So do we have evidence to call them liars, to say, you know what, you're wrong? Do we have the evidence? No, because 24 lies within the interval. Good. 24 is within our interval. Barely, but it's still within our interval. Okay.
By 0.910.
Yep. Not even a full chocolate chip. Okay. So there was one like 5-6 years ago, I think, where someone sued Subway for, they said their foot long was in actually 12 inches. No, their foot long sandwiches, their foot long sandwiches are supposed to be 12 inches. And someone sued them and said, hey, you're not, you're lying, pretty much you're lying to your customers and saying it's 12 inches because it's not 12 inches, it's less than 12 inches. So guess how they proved it in court that they were wrong? They actually won. They actually won it. They actually won the. It wasn't a frivolous lawsuit. They actually won a judgment against Subway. This was in. This wasn't in the United States. It was in Australia. And they won some money. How did they do that? They did a confidence interval. That's what they did. They used a confidence interval. They took a sample. Their sample was backed up, done correctly, and they said, hey, if our sample is true, if our sample mean is true, I'm guessing the sample mean was less than 12 inches. If our sample mean is true, that means your sandwiches, the true mean, the true average of the length of your foot long sandwiches is between this and that. I don't know what it was, but obviously 12 inches was not in the interval because they said, because they lost. They lost, the Subway lost the
This was in Australia?
This was in Australia, yeah.
They use the metric system over there? How are they going to know what a foot long is?
Well, whatever they call it there, I don't know. Well, even if they don't, even if they don't use, like, what meters are, right? Centimeters on your, so I mean, they're not dumb. They know what it is. So even if they don't use it, they can still convert it, right? So, yep. So that's what's done. So what I want to tell you guys is think about this back of your head, because after AP test, this is what we do. You're going to do some research. So you're going to use a confidence interval to answer a question like this. What is the true mean number of Chips Ahoy chips in a cookie? What is the true mean length of a Subway sandwich? And then you have to do some research to figure that out, and then figure out using a confidence interval what it is. So that's one of the things we do after, at the end of May. That's one of the things I have you guys do. So you guys got to do your own research to come up with data. One of the things you have to do is come up with data. So whether that means researching it on the internet or actually run your own thing, run your own. I think someone did, how many licks does it take to get to the center of a Tootsie Roll Pop? Someone did that. So they conducted their own data to do that, and they got enough data points, and they were able to do it. And they're saying, this is truly the number. I am this % confident that between this and this is the true number of licks it takes to get to the center of a Tootsie Pop.
You need like a full team to figure that out, dude.
No, it wasn't that bad. So whatever is you're curious in, start coming up with ideas, because that's the hardest part. The hardest part is sitting there and thinking, in May when the clock is ticking, what do I do? What do I do? So start thinking about it, write it down somewhere so that when we do it, you're like, okay, I know what I'm going to do.
I want to do something really stupid.
Okay?
What is the true mean number of wings a Red Bull gives you? Gosh.
Whatever you guys want to do.
We just stick to my idea. Come on. Suing a